Question 6, the longest one of this first section, and the tomato farmer is squeezing all of his tomatoes to test them. Well, we don't want him to squeeze every single one of them because then he might put his thumb in all of them. So this is called, of course, testing to destruction. Not quite destruction here, but he might damage his tomatoes. So I wouldn't advise him to test every single one. Maybe just one per box or something like that. Now, this is quite a fun question. Trying to find the estimate for the mean. We've got groups here. So the first thing I need to do is figure out, well, what's the midpoint of these groups? And if you add the two ends together and divide by 2, you can get each of these ones here. And of course, what we'd normally do to find out the mean is we'd do this times by 7, this times by 8, this times by x, and this times by that, and then we'd divide by the number there were. Well, we're going to have to put some algebra in this. Let me use the calculator. Just pause for a second. And magically all the numbers appear. So what I've just done, I did 114.5 times 7, plus this times 8, plus this one times x, this one times 10, and this one times 4. And of course, in a normal way, you'd add all of these things up and divide by how many there are. How many are there? 15, 25, 29 plus the x, and that equals the mean. So you've got an equation to solve. Magically, I've just added these numbers here together to get the 3860.5, and I've multiplied that up to the other side. So 29 times 133.5 gives me this. Last bit to take those from both sides. Well, conveniently, that's just going to give us 1x on this side here, and on the other side, so take away 3860.5 gives us 11. X is equal to 11. Now, look, if that came up to be a funny number, not a whole number or something ridiculously large, I would think I'd done it wrong. Look, 11 is around the range of that data, isn't it? So the next part of this is to then actually find out the standard deviation, and perhaps then we'll just go into our statistics menu to do that. So we're going to do a one variable statistic here. I need to put the frequencies on this calculator. Can you remember how to do that? Frequencies on, and so down here I'm going to put in these midpoints that we used, 141 and 124.5 and 134.5 and 144.5. I could pause again, I suppose, and 154.5. And the frequencies that we've got here were 7 and 8 and 11. We just worked that one out, and 10 and 4. Putting the numbers into the calculator, come out the calculator, and then I just want my one variable statistics there. And you can see our standard deviation. Our standard deviation here is 12.4. You can check our mean again there as well, can't we? Look, 133.5. That's good. That's what we wanted it to be. That one there. So our standard deviation is 12.4. The second farmer says that theirs were more consistent because they had a standard deviation of 10.1. And so actually you'd say, well, yeah, actually they do look a little bit more consistent, so I would agree with them. It does look to be a little bit more consistent, although I would worry that I had a sample of just 5 tomatoes there. So although it is lower, the sample size is not as good.